friends, very good afternoon to all of you and welcome to our channel Genius Structures. I am your host Dr. Suman Kulkarni. I have received an overwhelming response for my last video released yesterday and I got as much as 900 minutes of watch time. So I am thankful to all of my viewers who want to engage my all the videos and they are liking my videos. So thank you very much. Today we shall continue with slope deflection method, one more type of symmetrical portal frame, and this will be again solved in details up to bending moment diagram on tension side. So let us start with our today's problem of symmetric portal frame. So here we can see this particular frame, and if you see the details, this is single base single story frame with AB and CD both columns subjected to 6 kilonewton point load, which is eccentric point load, and beam BC, it is subjected to a UDL of 20 kilonewton per meter throughout the span. If you see moment of inertia for AB and CD, both the columns, I values are same, 1I, and for beam it is 2I. Span of beam BC is 2 meter, height of columns is 4 meter. So the sway of the frame is not possible in this case. So this is a non-sway type of portal frame. Okay. So as usual, our first step will be to find out the fixed end moments. Instead of fixed end moments, our first step will be to find out what is kinematic indeterminacy of this frame. So just like previous symmetric portal frame, this portal frame is also having kinematic indeterminacy as 2. So which are those two Ki values? They are again theta B and theta C. Now how these two are there? So we know degree of freedom per joint for a beam or a frame is 3. How many joints are there? A, B, C, D, 4 joints. So 3 into 4 is 12. From 12 you subtract these 3 degrees of freedom because it is fixed. One more fixed end, so 3 more. So 12 minus 6 is 6. Then how many number of members are there? AB, BC, CD, 3. So 6 minus 3 is 3, and there is no sway, lateral sway of the frame. So you subtract this one more sway. So 3 minus 1 is 2. So those two unknown displacement quantities are theta B and theta C. Okay. So second step will be finding out fixed end moment. So before going to fixed end moment, I would like to tell you here that there is one relationship between these two. What is that? Theta B is equal to minus theta C. How? Symmetric portal frame. Okay. Then fixed end moments. So let us find out this. MFAB is minus WAB square upon L square. So it is minus 6 into 3 into 1 square upon 4 square. So it is minus 18 upon 16. So let us calculate this value. It is minus 1.125 kilonewton meter. Next, MFBA. What will be MFBA? Plus WA square B upon L square. So it will be plus 6 into 3 square into 1 upon 4 square. So 6 into 3 square upon 4 square. So it is 3.375. 3.375 kilonewton meter. Now MFBC. what will be MFBC? Minus WL square upon 12. So it is minus 20 into 2 square upon 12. Okay. So let us find out this value also. So it is minus 6.67 kilonewton meter. So these are fixed end moments. Now we are not going for calculating the fixed end moments further. Why? Because this is a symmetric portal frame. So out of finding out all 6 fixed end moments, we will find only 3 values because of symmetry. Because other 3 will be equal and opposite of these 3 values. Okay. Now we will come to slope deflection equations. So step number 3. Slope deflection equations. So what are these equations? Let us find. MAB, we know what is the equation. 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L minus MFAB. So here theta A and delta are 0 because joint A is fixed. So there is no rotation, no theta value. There is no sway of the frame. So delta is 0. I value for column is 1I. L is 4. So 2EI by 4 into bracket theta B. MFAB is 1.125. So overall the equation is 2EI by 4 is 0.5 EI. So 0.5 EI theta B minus 1.125. So first equation is over. Second, MBA. What will be MBA equation? 2EI by L into bracket interchange of coefficients of theta A and theta B. Last term is plus MFBA. Okay. So again calculate this value. So MBA is 2EI by 4 into bracket 2 theta B. Again theta A delta 0. MFBA 3.375. So how much is this? 2 into 2 4. 4 by 4 is 1. So EI theta B plus 3.375. Then MBC. What is MBC? 2 EI by L into bracket 2 theta B plus theta C minus 3 delta by L minus MFBC. Here I value for span BC is 2I. So carefully substitute 2E into 2I. L for span BC is 2. Then 2 theta B plus theta C, both are unknown. Theta B, theta C, both are unknown. MFBC is minus 6.67. So here we will substitute theta C as minus theta B. From this relationship we will substitute theta C as minus theta B. So 2 theta B minus theta B is 1 theta B. 2 into 2 4 into 2 8. 8 by 2 is 4. So it will be 4 EI theta B. Correct? So instead of this 2 theta B minus 1 theta B is 1 theta B only. So 2 into 2 by 2 is 2. Correct? So this will be 2 EI theta B. This will get cancelled. This will become minus theta B. So 2 theta B minus theta B is 1 theta B in the bracket. So 1 theta B into 2 EI theta B. Okay, so 2 EI theta B minus 6.67. Okay. Next step, again we will stop here. This step we will stop here because due to symmetry, other equations will be equal and opposite, remaining 3. So now step number 4 is equilibrium equations. So what are the equilibrium equations? How many unknowns? Only one is there, theta b. So we need one condition of equilibrium, that will be at joint B. At joint B, what will be that condition? MBA plus MBC, it is equal to 0. Okay, MBA plus MBC is 0. So MBA is EI theta B plus 3.375. MBC is 2 EI theta B minus 6.67. Add these two equations and equate to 0. So this is 2, this is 1, so this is 3 EI theta B. Okay, 3 EI theta B, it is equal to 6.67 minus 3.375. So that will be 3.295. 3.295. So this will give us EI theta B as how much? 3.295 divided by 3. So it is 1.1. Okay, 1.1. So EI theta B is 1.1. So using this equation, we will get another unknown, EI theta C as minus 1.1. Simple. Just substitute theta B as minus theta C. So EI theta C becomes minus 1.1. Now we will find final moments. So let us calculate these values. So step number 5 is final moments. So what are final moments? MAB, it is equal to, substitute here the values. MAB is 0.5 EI theta B. So how much is EI theta B? 1.1. So 0.5 into 1.1 minus 1.125. So answer is minus 0.575. MAB minus 0.575 kilonewton meter. Then MBA, what will be MBA? 1.1 plus 3.375. So it is 4.475. 4.475 kilonewton meter. Then MBC, what is MBC? 2 times 1.1 minus 6.67. So answer is minus 4.47 kilonewton meter. So these two must be equal and opposite. Then MCB, what will be MCB? If you are comparing this CB, it has to be equal and opposite of BC. What is BC? Minus 4.47, so it is plus 4.47 kilonewton meter. Then CD, MCD will be equal and opposite of BA. So BA is plus, so this will be minus 4.475 kilonewton meter. And last one MDC, it has to be equal and opposite of MAB. So it is plus 0.575 kilonewton meter. Show these values here. So this is 0.575. Then plus and minus 4.475. Here again same 4.475, and last one is clockwise 0.575. So now we have got final moments. Now we have to get reactions, draw SFD and then BMD. Okay. So for that we need to calculate first of all reactions. So how to get these reactions? Get free body diagram of all members one by one. So we need horizontal reaction on joints A, then joint D. So we will take only column AB because here it will be equal and opposite of AB. So column AB, if I draw free body diagram, so here we have end moments 0.575 here anti-clockwise, then clockwise 4.475 here, then external load of 6 kilonewton here. This is 1 meter, this is 3 meter. So I will assume horizontal reaction at A towards left. This is my assumption. I will just cross check whether my assumption is correct or not. If my calculated answer of HA is correct, positive, then I will say my assumed direction is correct. I will take summation of moment about A, not A, B. So this is 4.475, then minus 0.575, then minus 6 into 1 and minus HA into 4. So this is equal to 0. From this I will find out now HA. So HA value is 4.475 into minus 0.575 minus 6 divided by 4. So answer is minus 0.525. So my answer is minus, it means my assumed direction is wrong. So HA is 0.525 kilonewton but towards left. Okay. So moment on this point I shall say E. So ME, see how much? Take moment about this section. Okay, from A. So ME, it is minus 0.575. Then this is towards left now. Please, I will make changes here. So plus 0.525 into 3. That's it. So let us see. 0.525 into 3 minus 0.575. So answer is 1. This comes to be 1 kilonewton meter. Okay. So question of this column is over. Now we will go to beam BC. Here, since there is UDL, we need to locate first of all point of zero shear force. Then we have to find bending moment at that particular zero shear force point. Okay, so this is 4.475 kilonewton meter. Now you will see that finding out point of zero shear force here is simple. It will be exactly at the center of the beam. Why? Because frame is geometrically symmetric as well as loading wise also it is symmetric. So this is 20 kilonewton per meter. Span is 2 meter. So this load has to be, or this reaction has to be equal, and it will be half of the total load. So this 4.475, it gets cancelled with this moment. 20 into 2, 40. 40 by 2 is 20. So 20 kilonewton is the reaction. Simple. Where will be zero shear force? At 1 meter from any of the support. Okay, so you take moment here at this particular point. So maximum bending moment will be 20 into 1 minus 4.475 minus 20 into 1 square by 2. Okay, so 20 into 1 is 20, 20 into 1 by 2 is 1 square by 2 is 10. So 20 minus 10, 10 minus 4.475. Let us find out. So that is 5.525. 5.525 kilonewton meter. So over rest of the things are same, that is mirror image. So now let us draw BMD on tension side. So we will draw that BMD and then our problem will be over. Okay. So here I will draw the bending moment diagram. One thing I will do is, I will first of all draw the deformed shape of the frame here, and as per the deformed shape I will draw BMD here. So anti-clockwise moment on joint A, so it is going to deform column on left hand side, so it is something like this. Okay. Then here is point load. So on point load there will be deformation like this, and then here. Then beam. Something like this. Actually the deformed shape should be symmetric, so I will redraw this. Yep, this is somewhat symmetric now, and its mirror image will be here. So yes, let me redraw it again. It is on right hand side here, so something like this. Yes, now it is correct. Yes. So this is deformed shape of the frame. As per this deformed shape, now we will draw BMD. So here we shall plot 0.575 on left hand side. On this end on right hand side. Then here 6 kilonewton point load. So on this location here we shall plot the ordinate on right hand side because deformed shape is on right hand side. So here 1 kilonewton meter, and on this end left hand side of the column. So join these 2 points. Then here 4.475 on left hand side. Here also on right hand side 4.475 kilonewton meter. Join these 2 points. This is again 4.475 ordinate. These two values, these are the directions above the reference line, and in the center below. So value is 1 kilonewton if you remember. Okay, and we have to join using parabolic line. Why? Because it is UDL. Okay, this is minus, this is plus, this is minus, yes. So this is our BMD, bending moment diagram. So guys, this is my analysis of this particular symmetric portal frame by slope deflection method. If you have not understood anything, you please do write in the comment. Thank you very much. And if you are new to this channel, do subscribe the channel and press the bell icon. Thank you.